Hello folks, this is Hugo Mantilla-Meluk. We are going to get into business and we're going to start with a short introduction for the first section of this series of video recorded classes, which is on phylogenetic comparative methods. Very interesting, very useful. So as an introduction, I would say that these methodologies, so they were developed back in the 1980s and they had become really um, popular, and they have expanded their application to test evolutionary hypotheses and phylogenetic hypotheses in different fields: evolutionary ecology, phylogeography, biogeography, analyzing different type of traits, from morphological traits to behavioral and also um, distributional traits. Well, what happened when a program or methodology become popular? Well, also the programs that we use to perform this type of analysis become more friendly for the user, and this is perfectly okay. I don't have problem with that. But a thing that potentially could happen is that we generate a distance between the conceptual background and the users. So one of the main objectives of this class is to narrow down this gap and provide you guys with some conceptual tools to understand this type of methodologies, and an invitation to do that with other type of analysis. So we always need to be really careful, we need to be curious, and we need to be critical um, with the tools that we use. And there's no analysis, there's no methodology that replaces your conceptual background. So this is the most important take-home message of this portion of this video recorded class. Well, back in 2009, British researcher R.P. Freckleton wrote a paper which a really nice title. The title of the paper is The Seven Deadly Sins of Phylogenetic Comparative Methods. And this paper basically asserts that the major problem, the major sin, is the lack of attention of users about the conceptual basis of the analysis that they used. Well, and the other thing that is actually highly recommended is to understand the historical framework in which this analysis had been developed, because it provides you with a better idea, more balanced idea on the potentials and the limitations of the analysis, and also give you an idea on the type of questions that the authors or the generators of these methods were trying to solve, which is really cool. And in the case of this particular phylogenetic analysis, has an extra advantage, uh, and is that we need to go back to northern Italy to track the history of the origin of this type of analysis. You guys might be familiar with the name Luigi Luca Cavalli Sforza, one of the major players on phylogenetic analysis. He basically set the statistics for the phylogenetic analysis that we perform today. And data come from a valley in Parma, relatively close to Turin. So this is another paper, a paper written by Cavalli, Sforza, and Edwards in 1963. Actually, there are two, 1963, 1964, some other papers. So this material is going to be part of the supporting material that you guys are going to have as part of these classes. Well, being said that, so we are going to jump into a short presentation, PowerPoint presentation. This is going to be the next video. And the objective of this presentation is for all of us to be on the same page on basic concepts on evolution. So natural selection, Darwin, what Darwin says, and time, very important. Time as a dimension in which evolution happens. And we have to make some differentiation between chronological time and generational time, and how to track characters. That was basically one of the major problems solved by the ideas of Cavalli Sforza, and is how to evaluate variances along all the branches of a phylogeny, which is very, very interesting. And from that, we are going to jump into some examples. Some of them come from mammals, but we are not only have mammals here, so we are going to have some birds, taking advantage of Colombia as a mega diverse country in terms of birds, the #1 country in terms of bird species, but we're going to work with hummingbirds. Hummingbirds are a really cool model because they are tiny animals with high metabolic rates, a lot of restrictions from the metabolic standpoint, and but they live in Colombia in one of the most restrictive environments, highland ecosystems. How it could happen, what we can say about, for example, body size, what kind of predictions we can make. So I'm testing that and some other biogeographic hypotheses. And from that, we are going to jump into map phylogenies on a real map. And this is part of my research. And this is the other way in which we do comparative analysis. And we are going to have some examples of bats from the Guianan region in Colombia and Amazon region that get into the highland of the Andes, also really cool. And at the very end of this, we are going to have a workshop with real data for you guys to play. We are going to use a free download program, R. So we are on the right track. We are already set for starting with this class. So thank you so much for the attention, and let's move to the practical part. Thank you.